Hello, the topic of today's lesson is to find area and perimeter of irregular shapes. Irregular shapes are typically shapes that are made up of more than one part. For example, we are used to, from last year, from third and fourth grade, working with perfect rectangles or perfect squares. Look at that perfect square. Not perfect at all. Or perfect squares. We also used to work with triangles. Well, what's happening this year is that we are combining parts of triangles and rectangles and squares to come up with different types of shapes. For example, let's consider shapes A, B, C, D, and E. Find the area of each of these figures. So let's see multiple strategies. So one of the first things I look at in these irregular shapes, I try to find shapes that I know. For example, squares, rectangles, and triangles. Let's look at this shape that is part of A. I see a perfect rectangle and I see another perfect rectangle. Now, these two rectangles are 2 by 3, so 2 times 3, they're equal, 2 times 3, so they're 6 centimeters squared each, 6 centimeters squared. Now, what to do with these triangles? What to do with these triangles? Well, I want you to think of another way. Let's take these two triangles, invert it, transform them, and combine them. Two triangles will make a rectangle, for example. So this is our rectangle, and if we split it down the middle, we have two perfect triangles, just like here. So let's take this piece and move it up, and we have another shape that is rectilinear, that is 2 by 2. So I would label it as 4 square centimeters. So altogether, the area of shape A is 6 plus 6 plus 4 equals 16 centimeters squared. Friends, do not forget to put your units down, okay? Notice that each square on this graph paper is 1 by 1 centimeters, making each of these squares to have the area of 1 centimeter squared. Now, let's take a look at shape B. Again, let's try first to find shapes that we can easily recognize. And I hope you see what I see. And that's this beautiful stretched out rectangle that is 2 squares across and 1, 2, 3, 4, 5, 6 squares down. So this piece is 12 centimeters squared. Now, what to do with these shapes? Well, I hope that you all recognize that they are triangles. I hope you can see it, that they're triangles. What we can do, again, imagine that we can take this triangle and shift it, translate it, rotate it over here. And what do we have? 2 triangles will give us a rectangle, and we have 2 squares. So this orange rectangle would be 2 centimeters squared. And altogether, the area of shape B is 12 plus 2 more equals 14 centimeters squared. Let's take a look at shape C. It's a little bit more complicated. Every time we see a shape, it will become more and more complex. And my friends, there are multiple ways to look at these shapes, and I encourage you to find different ways. I'm only showing you what I see and from my point of view, but if you see it differently, you are not wrong as long as we get the same answers. So, step 1, let's take a look at, I'm thinking of something else. Let's take a look at this rectangle in the middle. We have a rectangle, right? We have a rectangle in the middle, something like that, right? I'm just going to try. Actually, I can try to shade it using my highlighter. Let's try to shade it using my highlighter. So let's take a look. What's the area of this rectangle that I just highlighted? It is a 3 by 4 rectangle. Therefore, it's 12 centimeters squared inside in the area. Now look at what else we have. Do we see these 2 squares? Yes, of course we do. I'm gonna shade it this way. That's another 2 squared centimeters. Now we have triangles. Well, we know what to do with triangles. We can think of two triangles. And so here is triangle number 1. Here is triangle number 2. And my friends, I hope maybe you see it slightly different. Here is triangle number 3. And here is identical, congruent triangle number 4. I hope you see these 4 triangles that I just highlighted in purple. Well, let's think about it. If we move and rotate this piece, we will create a rectangle that measures 2 square centimeters. And if we take one of these pieces and rotate it just like this, we will create another 2 square centimeters. 2 triangles make a rectangle. Notice this. These 2 particular triangles, of course, something like this, right? I hope you see what I see, right? These 2 triangles can come together to form a rectangle. So let's compute the total area of shape C. The total area of shape C is 12 plus 2 plus 2 plus another 2, right? We got this 2, we got this 2, and it's all together. We have 12 plus 8 plus 6 is 18 squared centimeters, or centimeters squared. Let's come down to this beautiful trapezoid shape D. I hope you remember that these shapes are called trapezoids. Again, I encourage you to look for simple parts, for simpler pieces. Do we notice that this internal rectangle is actually not only a rectangle, it's actually a 4 by 4 square, right? This side is 4, this side is 4 square units. So this piece is 16 centimeters squared. And now I do like my purple color. Let's consider this triangles. Let's consider this piece and let's consider this piece. And again, I hope you notice that when we take these 2 triangles and we move them and combine them, we can create a square, a rectangular shape that is 1, 2, 3, 4 square units. So altogether shape D is 16 plus 4 equals 20 centimeters squared. Now finally, let's take a look at shape E. I'm going to delete this piece that's in the way. Shape E. Well, shape E is also quite interesting. We have a rectilinear shape. It's 1, 2, 3, 4. It's not a rectangle, but it is a quadrilateral. Not all angles are right, correct? Not all angles are 90 degrees. So let's consider these 2 parts. Okay, we have this triangle that I'm shading blue, and let's consider its area. It is 3 by 4. 3 times 4 is 12 squared centimeters. Now, what to do with this triangle? Let me highlight this triangle, okay? Let me see. What color can I find to highlight the triangle? Let's make it orange. So we have this triangle, and we're trying to find its area. My friends, I want you to think of a different method. You know, try to complete a rectangle, right? Now, if we think of this piece as a full rectangle, its area would be 3 by 4. So its area would be 3 times 4 equals 12 squared units. But we don't need a full triangle. We only need a half of it, right? And half a rectangle makes a beautiful triangle. So 12 split into 2 parts is 6. I'm going to label it here, 6 square units. And all together, the shape E, the area, of course, this is also area of shape E, is 12 plus 6 equals 18 centimeters squared. Now, my friends, I will let you answer the questions underneath this exercise. Which shape has the greatest area? Is it A? Is it B? Is it D? Which shape? We have 18, 16, 20, and 18. So, of course, in this case, It's shape D has the greatest area. Which one has the smallest area? The smallest area is shape B, right? B equals 14. And which two shapes have the same area of C is the same as area of E. Okay, wonderful. Now let's take a look at more additional exercises. Now for number one, we are on page 124. So I'm going to label it page 124. For example number one, I welcome you to think of another strategy. Let's consider the entire rectangle. Let's consider the entire rectangle. And let's first find the area, step one, area of this rectangle. Well, we know that it's 1, 2, 3, 4, 5. It's a 5 centimeter by 1, 2, 3, 4, 4 centimeters. So the area is 5 by 4, which gives us 20 centimeters squared. However, I want you to think that we do need to cut out as if you took imaginary scissors, and you have to cut out these 4 corners which have a shape of a triangle. So step 2, right? Let's consider the areas of these triangles, right? This is the area of these triangles, and these areas are, well, if the full square is 1, half of it, this piece would be a half. This piece would also be a half of a square centimeter. This piece would also be a half of a squared centimeter. So we have 4 such corners whose area is half, and therefore altogether they add up to 2 centimeters squared, making the total area, so step 3, right? The total area of this shape is 20 minus 2 equals 18 centimeters squared. The answer is 18. I hope you see it the same way I do. Now, let's take a look at shapes in part 2. I would only like to cover these ones. I would only cover B, D, and F and allow you to solve for ACE on your own. So let's consider this shape in B. I want you to see that we have 2 separate triangles, right? I'm going to use a highlighter, right? So this is a small blue triangle, and this is a larger orange triangle, okay? Now, I hope your eyes are getting used to it, that if we were to consider the entire rectangle, it would be 2 square units, but we need to half it, divide by 2. So this piece is 1, okay? This piece is 1. Similarly, if we consider the entire rectangular shape, it would be 1, 2, 3, 4 units, square units, but because we only need a triangle part, which is a half of it, we divide it by 2 equal parts, and it's 2 centimeters squared. So this piece is 2 centimeters squared. And altogether, this area is, area B equals 3 centimeters squared. Next, let's consider the shape in D. Again, I welcome you to notice that we want to find the area of this shape, which is a perfect right triangle, right? We have one right angle. I hope you do remember from 4th grade, this is your 90-degree angle. We have a right triangle. Well, how do we find this area? Again, I welcome you to consider the entire rectangle first. The area of this big rectangle is 1, 2, 3, 4, 5, 6 by 2. So 6 times 2 is 12. However, we only need an area of a triangle. Therefore, we need to divide it by 2, and we get 6 centimeters squared. So this piece is 6 centimeters squared. Finally, look at F. We have a lot going on in F. Let's go step by step. Again, I encourage you to find triangles everywhere you see, or triangles or rectangles. So here is one. Here is one triangle. Beautiful, right? Let me highlight it. This is triangle number 1, right? We also, I'm going to pick up a different shape. I also encourage you to see, we can think of a rectangle like this, right? We have a rectangle, that's part 2, that's another component. And then, what else can we see here? What else can we see? Let's find purple color. I hope you see these 2 pieces, right? These 2 pieces. And each of this is 1/2, correct? Each of this is 1/2. And then I hope you also see this triangle, right? I hope you see this triangle that we need as part of the shape. Now, let's go looking for area. Step 1, this piece, let's consider the whole rectangle first. The whole rectangle is 1, 2, 3, 4, 5 squares. Therefore, half of it, it's 5 divided by 2 is 2.5 centimeters squared. That's just one part. Here it's simple. 1, 2, 3, 4. This piece is 4 centimeters squared. It's a rectangle. This each of these is a half. And finally, this triangle, again, consider the full rectangle. That would be 3. So a half of that is 1.5. Now let's add all these parts together. Very careful not to make mistakes in mathematics. So let's add 2.5, that's the blue part, plus 4, that's the orange, plus 1/2, plus another 1/2, that's the purple, and plus 1.5, that's another purple. And all together, my friends, your area should be equal to 9 centimeters squared. I welcome you to find different solutions. We all look at things slightly different, but we should all get the same areas. I hope you enjoyed this lesson. Stay tuned for more.